Welcome back to the channel. As CBSE board exam for class 12th are very near, so I have decided to make some videos which can help you in your revision. So I have chosen chapter solutions, and for this video we will start with the 5 questions which could help you in your revision. The very first question is concentrated nitric acid used in the laboratory work is 68% nitric acid by mass in aqueous solution. What would be the molarity of such sample of acid if the density of the solution is given 1.504 gram per ml? So I will denote solute with A and solvent with B. We need to find out the molarity. So formula of molarity is moles of solute and divided by volume of solution in liter. So we need to find two things to find the molarity: moles of solute and then volume of solution in liter. What they have given us, they have given 68% nitric acid by mass. It means if we have total mass of solution is 100 gram, then we would have mass of nitric acid is 68 gram. So they have given us mass of nitric acid, and we know the molar mass of nitric acid, which is 63 gram per mole, right? So from this we can find out the moles of A. Moles of A would be given weight of nitric acid divided by molar mass of nitric acid. It would be 68 by 63. This is the moles, right? In next we can find out the volume of solution, because we know the weight of solution, which is 100 gram, and the density is given. So density is equals to density of solution is equals to weight of solution upon volume of solution. The density is in gram per ml. It means weight of solution we have to take in gram and volume would be in ml. This value is equals to 1.504 gram per ml. So weight of solution is 100 grams, and the volume of solution we can find, let's suppose, which is Vs. Okay, so volume of solution would be equals to 100 upon 1.504. This would be in ml, but we need to use it in here liter, so divided by, we need to divide it by 1000. 100 into 10 to the power minus 3 divided by 1.504. So this is the volume of solution. So if we just put the values here, molarity of the solution would be moles of A, which is 68 divided by 63, and the volume of solution in liter is 100 into 10 to the power minus 3 and divided by 1.504. On solving it, you will get the molarity, which is approximately equals to 16.24 mole per liter. Okay, so this would be our answer. This would be our answer. This molarity is around 16.24 mole per liter. So we move to the next question. Okay, so here next question says that how many moles of 0.1 molar HCl are required to treat with 1 gram mixture of Na2CO3 sodium carbonate and NaSCO3 sodium bicarbonate containing equal molar amounts of both. So let uh, X would be given weight, like weight or mass of Na2CO3, and Y would be weight of sodium bicarbonate, NaHCO3. So we need to know the molar mass of Na2CO3, which is equals to 106 gram per mole. We will going to use this value, and molar mass of NaHCO3 is around 84 gram per mole. So they have given us 1 gram mixture of balls, so we can write x plus y would be equals to 1, right? And they have also given the moles of both the components are equal, so we can write moles of Na2CO3 would be equals to moles of NaHCO3. How we can find out the moles of sodium carbonate, which is equals to given with x divided by molar mass, which is 106. So x divided by 106 is equals to y upon 84. As we know, x plus y is equals to 1, so we can substitute y 1 x upon 106, which is equals to, we can substitute y with 1 minus x divided by 84. On cross multiplying, we'll find out the value of x. So 84 into x would be equals to 106 minus of 106x, right? So here it would be 190x would be equals to 106. Value of x would be 106 upon 90. The x sorry 190. X is the weight of Na2CO3. So can we find out the moles of Na2CO3? Yes, moles of Na2CO3 would be x upon 106, and this x upon 106 we will get 1 upon 190, right? As both moles of Na2CO3 and NHCO3 would be equal, so this would be also equals to moles of NaHCO3. Okay, so we need to find the reaction here. Na2CO3 react with HCl and forms NaCl solution, sorry, NaCl and H2O and CO2. As here 2 moles of sodium, we need to multiply it with 2, and here also the stoichiometry of HCl would be 2. It means like 1 mole of sodium carbonate react with 2 moles of HCl, and NaHCO3 when reacted with HCl, it will form NaCl, H2O and CO2. It means NaCO3 react with 1 mole of HCl. Okay, so we can just write 2 moles of Na2CO3, sorry, 1 mole of Na2CO3 needs 2 mole of HCl, and 1 mole of NaCO3 needs 1 mole of HCl. So in total we need 3 moles of HCl, right? If we have this, we need 3 moles of HCl, but how many moles of Na2CO3 we'll have? 1 upon 190. It means the HCl required to neutralize Na2CO3 would be 2 times of mole of Na2CO3. So here we need 2 into 1 by 190 mole of HCl, right? And here we need 1 upon 190 mole of HCl. So total moles of HCl required is 3 upon 190 moles, right? So as we know, molarity of HCl would be equals to moles of HCl divided by volume of solution. As we need volume of this solution in ml, so we can multiply it by 100, sorry 1000. So we know moles of HCl, we also know molarity of HCl, which is equals to 0.1 as it is given. So from here we can find out the volume of solution in ml, which is equals to around 157.8. so this would be our answer here. This would be our final answer. Okay, we'll move to the next question. Okay, an anti-freezing solution is prepared from 222.6 gram of ethylene glycol and 200 gram of water. Calculate the molality of the solution. The density of solution is this 1.072 gram per ml. What would be the molality of the solution? So The solute here, let's suppose, is ethylene glycol, which is C2H6O2, right? And B would be water. Here weight of A is given weight 2 to 2.6 gram and 200 gram of water. Okay, so calculate the molality of solution. We need to find out the molality. So to find the molality would be equals to moles of A divided by weight of B in kg, right? And molar mass of ethylene glycol is around 62. You can easily find out. So moles of A would be 2 to 2.6 divided by 62, and weight of B is 200 grams, so we need in kg, so we will divide it by 1000. On solving it, you will get molality, which is equals to 17.9 mole per kg. Okay, so now we need to find out the molarity. Molarity would be equals to moles of A divided by volume of solution in liter. So our target is to find the volume of solution. We have the density of solution, so we can relate the density with the volume. How? Volume of solution, weight of solution would be equals to weight of A plus weight of B. Weight of A is 2 to 2.6 gram and 200 grams of weight of B. In total, it will give us 422.6 gram weight of solution. As we know, the density of solution is equals to weight of solution divided by volume of solution, and weight of solution is for 22.6 gram. Weight volume of solution we can find out from here, and the density is 1.072. Volume of solution would be 442.6 divided by 1.072. This volume is in milliliters, so we need to divide it by 1000 to get it in liter. So on putting the values, the moles of A is 2 to 2.6 divided by 62, and the volume of solution which we have found out is 442.6 into 1.072 into 10 to the power 3. On solving this, you will find the molarity, which is equals to approximately 9.1 mole per liter. So this would be our molarity. Okay, so now we move to the next question. This question said that heptane and octane form ideal solution. Okay, the vapor pressure of two liquid component are this and this respectively. What would be the pressure of the mixture if 26 gram of heptane and 35 gram of octane is given to you? So let's suppose A is heptane, B is octane. Okay, so given weight of A is given, which is 26 gram, and weight of B is 35 gram. We can easily find out the molar mass of heptane, which is equals to C7H16. If we're going to solve it, we'll find out around 100 gram per mole, and molar mass of B would be 114 gram per mole, right? So as it forms a ideal solution, so we can use total solution pressure would be equals to P naught of A into mole fraction of A plus P naught of B into mole fraction of B. So P naught of A is given, which is equals to 105.2 kilopascal, and P naught B is given to us, which is 46.8 kilopascal, right? So we need to find out the mole fraction first. So for that, moles of A would be equals to weight of A divided by molar mass of A, which is equals to approximately 0.26 moles, and moles of B would be around 35 divided by 114, and you will get it around 0.307 moles. So we need to find out the mole fraction of A. Mole fraction of A would be equals to moles of A divided by moles of A plus moles of B. On an approximate mole fraction of A, you will get 0.458, and mole fraction of B you can easily find out by 1 minus moles of A, and it will be approximately equals to 0.541. Okay, on putting the value, total pressure would be equals to 105.2 into 0.458 plus 46.8 into 0.541. It will give us total pressure approximate to 73.8 kilopascal. Okay, so we'll move to the next question of this video. Okay, calculate the mass of non-volatile solute having the molar mass this, which should be dissolved in 114 gram of octane to reduce the pressure to 80%. So let's suppose A is that non-volatile solute, non-volatile solute. Okay, so molar mass of A is given, which is 40 gram per mole. We need to find out the weight of A. Let's suppose it is x gram. We have given with a B, which is octane, and weight of octane is 114 gram. As molar mass of octane is 114 gram per mole, so we easily know the moles of A would be 1. As delta P upon P naught of B, P naught of B is the pure pressure of B, which is octane, would be equals to mole fraction of A. So how we can find out the delta P? Delta P would be P naught, P naught of B minus of PS divided by P naught of B. So what is P naught of B? P naught of B, it is said that the pressure is reduced to 80%. So let's suppose if P naught B is 100, the pure vapor pressure is 100, and it reduced to 80, so PS would be 80, and divided by P naught B 100, right? This would be equals to 0.2, and mole fraction of A would be equals to moles of A upon moles of A, and moles of B is equals to 1. Okay, so this is moles of B. On cross multiplying, 0.2 moles of A plus 0.2 would be equals to moles of A, and here moles of 0.8 moles of A would be equals to 0.2, and moles of A would be equals to 1 by 4. Moles of A would be equals to given weight upon molar mass. Given weight is x and molar mass is 40. So on solving it, x would be equals to 10 gram. Okay, so thank you for watching the video. I'll come with more question in the next video of this chapter. Thank you very much.